Welcome to The Explainer. Look, we hear a ton of noise about artificial intelligence these days, right? But today, we're cutting through all that. We are translating a really dense, landmark 2025 study out of Yale to figure out exactly how AI scaling laws are going to impact your daily job, your earning potential, and the broader economy. This research actually gets to the ground truth of what happens when high-skilled professionals truly integrate large language models into their daily grind.
Let's kick things off with a massive and honestly kind of shocking finding right out of the gate. In an experiment with over 500 professionals, giving consultants, data analysts, and managers access to an AI model resulted in a 146% increase in total earnings per minute. That is a staggering number. It essentially means that just by introducing standard AI assistants into the mix, the total economic value a person generated more than doubled.
Now, seeing a jump like that naturally begs a pretty high-stakes question. Is AI actually making you richer by elevating the quality of your work, or are we all just doing our jobs faster? Is it a speed boost, or is it genuinely making you better at what you do? We need to look closely at the data to see where all this new economic value is actually coming from. Okay, Section 1, the baseline AI advantage. Let's look at its actual impact on work quality. To really understand this, researchers had professionals use 13 different large language models to knock out real-world tasks. And the immediate financial impact? It's crystal clear. Workers flying solo, relying just on their own skills, were pulling in about 73 cents a minute. But equip those same people with AI models? Boom! Their earnings skyrocketed to $1.79 a minute. And because the researchers literally doubled the pay for hitting expert-assessed quality grades, this leap represents both a super high completion rate and a massive quality bonus. So, let's break down where that growth actually comes from. Because this boom isn't just about speed. Yes, about 53% of that total earnings increase comes from simply finishing tasks faster. But here's the real kicker. Nearly half of the gain, 47.4% to be exact, comes directly from higher quality work. The AI actively pushed more workers over that expert quality threshold to earn performance bonuses. It's really a dual engine of speed and excellence. Moving right along, Section 2, time is money. Let's see these scaling laws in action.
Listen, the AI you're using today, it's not the AI we'll have tomorrow, and the study identifies a robust calendar time scaling effect to prove it. The data shows that every single year of frontier model progress automatically shaves 8% off the time it takes professionals to complete a task. Think about that, compounding year over year. Just by existing in an environment where frontier AI tools are updating, your workflows are naturally compressing.
We can actually decompose the mechanics of this time-saving progress into two distinct engines. When we break down exactly why these models are making us faster, 56% is driven simply by scale, literally throwing more raw training compute at the models. The other 44% comes from algorithmic and data improvements, meaning researchers are working smarter, optimizing the architectures, and training way more efficiently. So it's this perfect mix of brute force and brilliant engineering.
All right, Section 3, the automation resistance. We're talking agentic versus non-agentic tasks. Now, keep in mind this massive productivity boost isn't distributed evenly across every single type of task you do. We need to split your work into two buckets. First, we have non-agentic tasks. These are your self-contained thinking tasks, stuff like interpreting data, hypothesis testing, or writing reports. Second, we have agentic workflows. These are the tricky ones. They require multi-step planning, procedural agency, and interacting with external tools. Think extracting data from a massive PDF, building a spreadsheet out of it, and then emailing it to your boss.
And we compare those two categories, the contrast is absolutely wild. Notice the steep earnings growth for those non-agentic tasks. We're talking an increase of about $20 an hour per year. AI is just eating through analytical work. But for the complex agentic tasks, there's a stubborn flat line. The growth there is only about $4.80 an hour. These multi-step, tool-using tasks are remaining highly resistant to current automation. So, for now at least, your human agency in complex workflows is still your most defensible moat.
Which brings us to Section 4, the human quality bottleneck. And guys, this is where things get a little counterintuitive. Okay, we've established that bigger AI models produce better work autonomously. But what happens when a human steps in to supervise and help the absolute best models out there? If a machine gives you an expert-level draft, does your human touch elevate it to pure genius? Or do you somehow get in the way?
The data completely exposes the human bottleneck here. Notice how pure AI quality, when it's graded blindly by experts, scales beautifully upward as training compute increases. The models are clearly getting smarter. But when we look at the human-assisted quality, it completely flatlines at a stagnant score of roughly 4.3 out of 7, completely regardless of how smart the underlying AI is.
Yeah, you heard that right. The crucial point here is that for intermediate and frontier models, humans actually cap the realized capabilities of the technology. We have a last-mile problem. The raw AI is churning out outputs that experts might grade a 5 or a 6. But when the human user gets hold of it, they edit it, tweak it, and actively degrade it back down to a 4.3, which is basically their own internal baseline of what is good enough. We are literally dragging superhuman outputs back down to our own level of mediocrity.
All right, zooming all the way out. Section 5, a 20% economic boom. Let's look at the macroeconomic impact.
To forecast the big picture, the researcher plugs these experimental findings into an aggregate growth framework known as Holton's theorem. Without getting totally bogged down in the academic weeds here, this is a highly trusted economic formula used to project the compounding effects of time savings across the broader economy. It basically looks at how many tasks are exposed to AI and how much cheaper or faster those specific tasks become.
Here is how the math shakes out. First, you take the 19.9% of all tasks in the economy that are currently exposed to AI. Next, based on that compounding 8% annual time reduction we talked about, you multiply that exposure by a staggering 175.1% average productivity boost projected by mid-decade. Finally, you adjust for the human element by multiplying all of that by the 57% labor share of costs in those exposed tasks.
Run all those numbers, and the study drops a bombshell. Continued LLM scaling could boost U.S. economic productivity by an astonishing 20% over the next 10 years. And keep in mind, that estimate only looks at the automation of existing tasks. It doesn't even factor in the potential for AI to invent entirely new industries or accelerate scientific research. We're talking about a massive, transformative leap in aggregate wealth.
Look, the time savings and this massive macroeconomic boom, they're virtually hard-coded into the scaling compute at this point. The tech is going to get faster, and the economy is going to grow. But considering what we just learned about human behavior is actually holding AI quality back and degrading those expert outputs, the ultimate question I want to leave you with is this. As this technology continues to scale, will you adapt to truly maximize its potential, or will you become the bottleneck?